Hello friends, hope you all are keeping well and staying safe during the tough times of corona pandemic. In today's video, as our continued endeavor to teach the concepts of flow cytometry and hematopoiesis, we will be covering step-by-step journey of B cell maturation with changes in CD markers and also the origin of all major B cell neoplasms including B lymphoma and acute lymphoblastic leukemia. After understanding the working principles of flow cytometry machine and interpretation of graphs, we also learned normal maturation pattern of myeloid series and CD markers of myeloid series on flow cytometry plots. If you have missed our previous two videos, there is a link you can see up for an easy understanding of this flow cytometry lecture. At the end of this video, you will be confident on the topics such as B cell hematopoiesis and the CD markers present on lymphoid precursors and mature lymphoid cells. You will also be able to interpret flow cytometry plots and separate a benign proliferation from a malignant one on flow cytometry. So let's begin with the must-know CD markers for B cell lineage. Welcome back to Pathogenesis, where we understand the disease. If this is your first time here, don't forget to subscribe and press the bell icon so that you don't miss any updates. Please motivate us by liking and sharing our videos. B cell neoplasms are clonal tumors of mature and immature B cells at various stages of differentiation. Each B lymphoma and acute lymphoblastic leukemia subtype bears a phenotypic resemblance to B cell at a stage of differentiation during the hematopoiesis. So, instead of mugging different CD markers for B lymphoma and acute lymphoblastic leukemia, if we just remember the normal postulated counterpart from which these B lymphoma and acute lymphoblastic leukemia arises, flow cytometry plots will never be a brain teaser again. B cell hematopoiesis can be divided into two phases. Early B cell differentiation is antigen independent phase, taking place in bone marrow and has been extensively studied using flow cytometry immunophenotyping. Once these cells are mature, they leave the bone marrow and go to secondary lymphoid organs such as lymph node, spleen and mucosa associated lymphoid tissue, where antigen-dependent phase of maturation takes place. Inside the bone marrow, there are 4 stages of B cell development, which can be identified during flow cytometry evaluation. First is pro-B, second common B, third pre-B, and finally mature B cell. Mature B cells are also known as naive B cells. Before understanding how to identify different stages of B cell on flow cytometry, we should know the lineage-specific CD markers for identifying B cells on flow cytometry. These are CD19, CD22 and cytoplasmic CD79A, which are present all throughout hematopoiesis cycle of B cells. These are pan-B cell CD markers and are a must for diagnosing B lymphoma and acute lymphoblastic leukemia on flow cytometry. If on flow cytometry CD19 is strong, a cell can be defined to be of B cell lineage. However, if CD19 is weak on flow cytometry, then only CD19 does not suffice to define B lineage, and at least one of the markers among CD79A, CD22 or CD10 should be present. On flow cytometry, Pro-B, the first stage of hematopoiesis, shows presence of all 3 B lineage cell markers. Now, let's just remember that Pro-B is an immature cell. So on flow cytometry, it will show immaturity markers that are CD34 and TDT. However, cytoplasmic mu chain, heavy chain, is not expressed at Pro-B stage. Pro-B progresses to common B stage and is similar to Pro-B except that they show presence of cytoplasmic mu chain and CD10 on flow cytometry. This is an important point which we all should remember, that cytoplasmic heavy chain first appears at common B stage. The presence of CD10 antigen or Kala antigen on B cells in flow cytometry defines the common acute lymphoblastic leukemia subgroup. CD10 is absent on rest of the stages of B cell development. Common B stage progresses to immature B cells or pre-B stage, which on flow cytometry are positive for intracellular immunoglobulin IgM while retaining cytoplasmic heavy chain mu. CD markers like CD10, CD34 and TDT are lost. These precursor B cells give rise to B acute lymphoblastic leukemia, which is labeled on flow cytometry based on the cell of origin as pro-B acute lymphoblastic leukemia, common B acute lymphoblastic leukemia, pre-B acute lymphoblastic leukemia and mature B acute lymphoblastic leukemia. Mature B acute lymphoblastic leukemia shows immunoglobulin light chain expression. Now let's move to evaluation of antigen-independent phase of B lymphoid hematopoiesis by flow cytometry. This phase is the origin of all B lymphomas. Precursor B cells which mature in the bone marrow may undergo apoptosis or develop into mature B cells. Mature B cells which are released from the bone marrow are also known as naive B cells, as they have never been exposed to antigen before. Naive B cells on flow cytometry are negative for both CD34 and TDT. They are often CD5 positive on flow cytometry. Naive B cells are small resting lymphocytes that circulate in the peripheral blood and also occupy primary lymphoid follicles and follicle mantle zones. They migrate from peripheral blood to lymph nodes where the second stage of B cell development takes place. Upon contact with cognate antigen, naive B cells undergo transformation, proliferate, and migrate into T cell zones of secondary lymphatic organs. A fraction of these proliferating B cells also differentiate into short-lived plasma cells that secrete antibodies of mostly IgM isotype and hence provide an initial wave of low affinity antibodies. The pre-germinal center mature B cell, which is CD5 positive on flow cytometry, has not undergone somatic hypermutation. It appears to be the normal B cell counterpart of most cases of mantle cell lymphoma, which have unmutated IgV regions. One subtype of small lymphocytic lymphoma and its leukemic relative, chronic lymphocytic leukemia, have mutated IgV regions and is pre-germinal center in derivation. So, if we remember that CLL and mantle cell lymphoma originates from the pre-germinal center B cell, we can identify these two B lymphoma on flow cytometry. Now, what is the immunophenotype on flow cytometry of a pre-germinal center B lymphoma? They are CD5 positive along with the presence of other pan B cell CD markers, that is CD19, CD20 and CD79A. Now let's move forward. As previously said, other antigen exposed B cells migrate together with activated T helper cell into the B cell follicles, which is the center of a primary follicle. They proliferate there and fill the follicular dendritic meshwork, forming a germinal center, where somatic hypermutation and heavy chain class switching occur. Now, before moving further, let's quickly learn what kind of cells a germinal center is made up of. It will be very useful when we will be analyzing flow cytometry of FNAC samples or lymph node biopsies for B lymphoma. A lymph node has three zones: a loosely associated network of follicular dendritic cells, T follicular helper cells, and germinal center B cells, also known as centrocytes. They together form a so-called light zone, whereas a dense area of quickly dividing B cells or centroblast can be recognized as a dark zone. The expanding germinal center displaces the locally residing resting B lymphocyte and compacts them into a mantle zone surrounding the germinal center. Germinal center B cells undergo multiple cycles of proliferation, and the constant region of the antibody heavy chain may be exchanged by class switch recombination. In the germinal center, somatic hypermutation also occurs in the IgV genes. Some cells switch from IgM production to IgG or IgA, responsible for secondary immune response. After several cycles of proliferation, mutation, and positive selection, germinal center B cells differentiate into either antibody-secreting plasma cells or resting memory B cells that leave the germinal center microenvironment. Germinal center centroblasts express low level of surface immunoglobulin on flow cytometry and switch off expression of BCL2. Therefore, they and their progeny are susceptible to apoptosis. Centroblasts also express CD10 as well as BCL6 on flow cytometry, a nuclear transcription factor also expressed by centrocytes. BCL6 is negative on flow cytometry in naive B cells and is also switched off in memory B cells and plasma cells. MYC is upregulated upon interaction of naive B cells with antigen and T cells by the action of BCL6 and is essential for germinal center formation. In short, mutated IgV, BCL6 and CD10 expression on flow cytometry serve as markers of cells that have been through the germinal center. So, if on flow cytometry we see cells which are positive for pan-B markers CD10 and have mutated IgV, we know these cells are from germinal center origin. Remember these as germinal center markers on flow cytometry for B lymphoma of germinal center origin. What are these lymphomas? We'll study in just a few minutes. Centrocytes are rescued from apoptosis and they re-express BCL2. Through interaction with follicular dendritic cells and T cells, centrocytes switch off BCL6 expression and differentiate either into memory B cells or plasma cells. Post-germinal center memory B cell circulate in the peripheral blood and account for at least some of the cells in the follicular marginal zone of lymph nodes, spleen and mucosa-associated lymphoid tissue. Marginal zone B cells of this compartment typically express pan-B cell antigens and the surface immunoglobulin on flow cytometry. They are negative for both CD5 and CD10. We will again remember this and use it later for interpretation of B lymphoma of post-germinal center origin on flow cytometry plots. Plasma cells produced in the germinal center enter the peripheral blood and home to the bone marrow. Plasma cells on flow cytometry are positive for IgG or IgA. They are negative for surface immunoglobulin and CD20 but express IRF4 or MYOM1, CD79A, CD38 and CD138 on flow cytometry evaluation. CD19 is present but is DIM positive. So guys, always remember that plasma cells are CD38 and CD138 dual positive and identifying PCs on flow cytometry would be easy. Now let's move to the part we all want to learn, that is diagnosing B lymphoma on flow cytometry. Diagnosing B lymphoma and acute lymphoblastic leukemia by flow cytometry is a challenge. Let's understand why. Many a times in flow cytometry, we get a sample from lymph node or peripheral blood to be tested for the presence of lymphoma. However, lymph node, as we know, might be reactive also, so it may show reactive lymphoid cell proliferation due to infection, or even peripheral blood lymphocytosis can be reactive. So now the question comes, how do we differentiate both the conditions on flow cytometry plots? The answer is to learn the CD markers. Each lymphoma subtype, as we know, bears a phenotypic resemblance to B cells at a particular stage of differentiation. So, instead of mugging different markers for lymphoma, if we just remember the normal postulated counterpart from which the lymphoma arises, identifying lymphomas on flow cytometry would never be a brain teaser again.
B lymphoma can originate from P-germinal center B cells, germinal center B cells, and post-germinal center B cells. Each B lymphoma has a peculiar CD marker signature to it, which can be read on flow cytometry. Let's start with B cell lymphomas originating from germinal center B cell. Germinal center B cell is the normal counterpart of follicular lymphoma, Burkitt lymphoma, and the germinal center B cell-like subtype of diffuse large B cell lymphoma or DLBCL. So, can you guess what would be the markers if we run flow cytometry on a lymph node involved by one of these three lymphomas? Flow cytometry plots would show cells positive for pan B cell CD markers along with CD10, BCL6 and mutated IgV. The cells would be negative for CD5. The activated B cell-like or ABC subtype of DLBCL resembles the post-germinal center plasmablast. Also, hairy cell leukemia has gene expression profile resembling a post-germinal center memory B cell. Flow cytometry plots of HCL and DLBCL show B cells with pan B cell markers and will be negative for CD5, CD10 and BCL6. Again, a post-germinal center immunophenotype. Mucosa-associated lymphoid tissue lymphomas, also known as maltomas, are B lymphomas which are extranodal in origin and phenotypically related to post-germinal center marginal zone B cells. Maltomas on flow cytometry show pan B cell markers and are negative for CD5, CD10 and BCL6. Plasma cell myeloma corresponds to a bone marrow homing plasma cell and are positive for CD38 and CD138 on flow cytometry, along with either kappa or lambda chain restriction. So that's all for today in flow cytometry. We sincerely hope that after listening to this video on flow cytometry in B lymphoma and B acute lymphoblastic leukemia, you all will be able to suspect and diagnose them on flow cytometry plots. If any doubts or queries regarding flow cytometry, please do write to us in the comment section and we would love to hear from you. If you have not subscribed, make sure you do now so that you don't miss your updates in oncopathology and hematology. For basics and working of flow cytometry machine and interpretation of flow cytometry plots, you can watch our first video on flow cytometry series, a link of which is given in description below. We hope you liked our video and stay tuned for next video on how to identify T cell lymphomas and T acute lymphoblastic leukemia on flow cytometry. Till then, take care.